Hi, this is Tom English again, and I want to follow up on our last video about graphing linear equations. And I mentioned briefly the form of the equation that we call the slope-intercept form. If we look at our previous equation, we said y is equal to 3x plus 2. And the form of the equation we call the slope-intercept is y is equal to mx plus b. And I think I mentioned the last time that b is, when x is 0, that shows you where it crosses the y-intercept. So that's the intercept portion of the equation. And the m, or the coefficient for x, tells us what the slope is. And in this case, we're saying our slope is 3. The slope I mentioned is the steepness of the line, and the more vertical it is, the higher the greater the slope. The more horizontal it is, the smaller the slope. And the slope is actually defined as the change in y over the change in x. Now, I've shown it here as a triangle, or the Greek letter delta, which stands for distance. So I would read this as the difference, rather, in y over the difference in x. Most kids first learn it as y2 minus y1 over x2 minus x1. Now, in this case, let's take some points that we know. Let's just take these 2 points where the y-intercept and the 0.15 and calculate the slope. In this case, we're saying if we look at the distance, or the difference between those 2 points, the y value, let's start with the 5, and we subtract the y value of the second point, which is a 2, and we end up with 3. So 3 is the difference in the y values. The x values, and this is the key, this is where a lot of kids goof up, is they go in one direction for y and a different direction for x, and as a result they get their signs mixed up. But let's go. We started with the 5, so we're going to start with the x value at that point. So that would be 1 minus, in this case it's 0, so the difference in the x's is 1, so the slope is 3. And I hope that you notice that that 3 is exactly what we had up here. So m, in this case, is 3. And we could have told that just by looking at this equation. When we look at this, we can see right away that the slope is 3 and the intercept is 2. A different way, instead of putting in points, calculating as we did the last time, by knowing the slope and the y-intercept, what we do is we would start with this point. We'd say, we know the y-intercept is at 0, 2, and then we say we calculate the slope to find the next point. And the slope, it says the difference in y is 3, so we would go up 3. 1, 2, 3. The difference in x is 1, so we're just going to go over 1 and we get the same point. We could draw a line between those two. Now, if we'd have calculated it differently, we could have ended up with a negative 3 over a negative 1. We'd still get a slope of 3. If we'd have turned these around, we could have gotten the same thing and maybe gotten our third point by saying, okay, if we go down 3, 1, 2, 3, and a negative 1 says we go back 1, we get this third point. So we can calculate the slope in 2 different ways. The key, though, is to recognize a positive slope. Any line with a positive slope will always start in this third quadrant and go up into the first quadrant. If the slope is negative, then we're going to be starting over into the fourth quadrant and finishing up in the second quadrant. Again, I challenge the students always, do that double check. When you have a line, you know it's going to be a positive slope. If you come up with a negative number for the slope, something's wrong. You probably got the x's and y's mixed up. Remember always to look at that. If it's going from lower left to upper right, it's a positive slope. If it's going the opposite from 4 to 3, or from 4 to 2, then we're going to have a negative slope. Thank you much.